How to Factor Binomials, Part 1 on Aiken's How-To Math. Let's talk about factoring binomials. That's polynomials with two terms. Again, every time you go to factor something, the very first thing you're supposed to check is the greatest common factor. Regardless if you're factoring binomials, trinomials, whatever you're doing, the very first thing you're supposed to do is check the greatest common factor. And I've got videos on how to check the greatest common factor. So that should be the first thing you should do. The second thing, once they give you a binomial, is you need to check and see if it can even be factored. And I'm going to go over the rules on how to check and see if you can actually factor one of these binomials. Here are the things you need to look for to see if you can even factor a binomial. First off, a binomial has two terms. In between those two terms, you have to have a minus sign. If it doesn't have a minus sign, then it's one that cannot be factored. The numbers that they give you, the coefficients of the two terms, those have to be perfect squares. Those numbers, you have to be able to take the square root of them. For example, 36 is a perfect square. You can take the square root of 36. The square root of 36 is 6 because 6 times 6 is 36. 16 is a perfect square. The square root of 16 is 4 because 4 times 4 is 16. 4 is a perfect square. 2 times 2 is 4. The square root of 4 is 2. However, a number like 10 is not a perfect square. You cannot take the square root of 10. There are no two numbers that are exactly the same that multiply together to give you 10. Therefore, 10 does not have a square root. Therefore, it's not a perfect square. And the other thing, any exponents you see in the binomial, they have to be even. You have to have all these in place before you can factor a binomial. You got to have a minus sign, the numbers must be perfect squares, and all the exponents must be even. Now that we've gone over the rules for which binomials can and cannot be factored, we're going to look at some examples and apply those rules. Those three rules are this: must have a minus sign in between the two terms. Each coefficient, each number must be a perfect square, and you have to have an even exponent. So this first example right here, x squared plus 4, this binomial cannot be factored because there is a plus sign right there in the middle. I'll look at the next one. Well, this next one has a minus sign. However, this one cannot be factored. The reason why, this 8, you cannot take the square root of 8. There are no two numbers that are exactly the same that multiply together to give you 8. So the reason this one can't is because 8 is not a perfect square. Let's look at the next one. Okay, one condition's met. It's got a minus sign in between it. This number right here, you can take the square root of 16. The square root of 16 is 4. However, all the exponents must be even. This right here is not an even exponent. Therefore, this binomial cannot be factored. Let's go to the next one. Minus sign. So far, that's good. Can I take the square root of 81? Yes, I can take the square root of 81. And I've got an even exponent. So this one right here, this can be factored. A lot of times people look at this one right here and they think, well, this one can't be factored. The reason why, they're thinking there are no two numbers that are exactly the same that multiply together to give you 1. However, they're forgetting the square root of 1 is 1 because 1 times 1 is 1. Once we determine that the binomial can be factored, here are the rules or the procedure that we're going to go through to actually factor it. So the first thing you're going to do is you're going to make two sets of parentheses. These two sets of parentheses represents the two factors that you're factoring this out into. What are you going to put inside those parentheses? You're going to take the square root of each number, each coefficient. That was a perfect square. You're going to take the square root of it and you're going to put that inside the parentheses. This is the reason that variables have to be even. You're going to split up those variables evenly to those two sets of parentheses. Once you do that, you're going to put a plus sign in one and a minus sign in the other set of parentheses. So this is our rules. This is the procedure that we're going to go through. Make two sets of parentheses, take the square root of each number, split the variables up evenly, put a plus sign in one, a minus sign in the other. Next thing we're going to do is we're going to apply this procedure to an example. So now our first example using this procedure. They're going to ask you to factor this binomial. Again, every time somebody asks you to factor something, the very first thing you need to look for is the greatest common factor. There are no numbers that they have in common. There are no letters that they have in common. So the greatest common factor is not going to help us factoring this one. But we just went over a procedure for factoring binomials, and that's what this is. Maybe we can factor this binomial. Some things we need to check. Make sure there's a minus sign. Make sure that you can take the square root or that this number is a perfect square, which it is. Make sure you've got an even exponent. I do have an even exponent. So we're going to go through that procedure. The procedure said make two sets of parentheses first. So that's what I'm going to do. I'm going to make two sets of parentheses. I need to take the square root of any number, and I need to split any variables up evenly because I've got an even exponent. Since this is in the front, that's what I'm going to do. I'm going to split this x squared up into x and x and put them in each set of parentheses there in the front. Since this is in the front, I'm going to put these two x's right here in the front of these two parentheses. So I'm going to put an x there and an x there. I'll look in the back. I've got a 4 back here in the back. It is a perfect square. That means I can take the square root of 4. The square root of 4 is 2. That means I'm going to put 1, 2 in the back of one set of parentheses, the other 2 in the back of the other set of parentheses. Now I need to put a plus sign in one of them and a minus sign in the other. I have just factored that binomial. So let's go through that procedure again with this one. I check and see if it has a greatest common factor. There's no greatest common factor. There is a minus sign. This is a perfect square, and I have an even exponent. This can be factored. I need to make two sets of parentheses. That's what I'm going to do. Look here in the front. This is x squared. That means I put 1x in the front of each one of those parentheses. I can take the square root of 36. The square root of 36 is 6. That means I'm going to put a 6 in the back. And in one set of parentheses, I put a plus sign. In the other set of parentheses, I put a minus sign. I have just factored that binomial.